What would happen if suddenly an unknown light appeared in the sky, intense, red and threatening, growing every second until it lit up the night as if it were day? At first, you might think it's just a bright star or some unusual atmospheric phenomenon. But then, the ground would start to shake, not because of an earthquake, but because of something much worse. The tides would run out of control, swallowing entire cities. Satellites would fall from the sky like red-hot stones. And on the horizon, the sun, that same star that has always been our safe beacon, would begin to waver, as if it were being pulled away. Now imagine, what if all this was caused by a rogue star, a monstrous celestial body from the darkest abyss of the universe, streaking through our solar system like a merciless predator? This may sound like science fiction, but what if I told you this is more real than you imagine? If a rogue star really invaded the solar system, what do you think would happen to Earth? Do you think humanity could find a way to survive a cosmic event of this magnitude, or would we be doomed to extinction? What's more, do you believe that science could develop technology capable of altering the trajectory of an errant star or preventing the gravitational collapse of the solar system, or would we be completely at the mercy of the forces of the universe? Leave your opinion in the comments. I want to know what you think about this scenario. Is there a chance of survival, or would this be the true end of civilization as we know it? I'm curious to see your theories. Who knows, some ideas here in the comments might even anticipate what scientists haven't discovered yet. There is evidence to suggest that this cosmic nightmare may be more than just a theory. And in this video, you'll find out why this might be closer than we think. Wandering stars. They are cosmic objects that wander through space without a fixed destination, without being gravitationally linked to a star system or a galaxy. They do not orbit a stable center like the Sun, and can traverse colossal distances, moving at speeds exceeding hundreds of kilometers per second. These stars are the result of violent events, such as collisions between binary systems, interactions with black holes, or extreme gravitational expulsions. When a star is ejected in this way, it becomes a cosmic traveler, passing through dense regions of space and potentially crossing paths with entire solar systems. The threat arises when a rogue star enters the zone of gravitational influence of another star system. In the case of the solar system, the orbital balance that keeps the planets on their current trajectories depends directly on the gravitational force of the Sun. If a wandering star came close enough, its mass and gravitational field could disturb this balance, destabilizing orbits and altering the movement of the planets. To understand the impact of this disruption, imagine the solar system as a perfectly organized billiard net. Planets, satellites, and asteroids are positioned on predictable trajectories, balanced by the gravitational forces of the Sun and giant planets such as Jupiter and Saturn. Now introduce a massive external force, the wandering star, through this network with a gravitational force capable of bending the space-time around it. The star could create gravitational distortions so intense that smaller planets would be pulled into new orbits or even ejected out of the solar system. Jupiter, which has an extremely strong gravitational field, could become a catalyst for chaos, being pulled toward the intruder star or attracting other planets into its altered orbit. Saturn, Uranus, and Neptune, which depend on Jupiter's gravitational stability to maintain their trajectories, could enter erratic orbits or collide with each other. Mars could be pulled onto a collision course with Earth or Venus, while the inner planets such as Mercury and Venus would have little chance of surviving the wandering star's gravitational pull. The asteroid belt between Mars and Jupiter would also be affected. The star's gravitational force could displace thousands of asteroids and comets, launching them towards the interior of the solar system. This would exponentially increase the risk of catastrophic impacts on Earth. A single collision with a large asteroid could release energy comparable to that of millions of nuclear bombs, generating seismic shockwaves, global-scale fires, and a nuclear winter that could last for years. But the danger would not be limited to the Earth's surface. The wandering star could alter the Sun's position and movement relative to the Milky Way. If the Sun were pulled into a new orbit, the solar system could be dislodged from its current position in the galaxy's spiral arm, leading to gravitational isolation that would leave the solar system drifting through interstellar space without the protection offered by the galactic magnetic field. This would make the solar system more vulnerable to cosmic radiation and interference from black holes or supernova explosions. The wandering star's proximity could also trigger catastrophic effects on Earth. The increase in gravitational force could trigger massive volcanic eruptions, releasing enormous amounts of sulfur dioxide into the atmosphere and generating a global cooling effect. Tectonic plates would be forced to move faster, resulting in planetary-scale earthquakes and the formation of tsunamis hundreds of meters high. The Earth's magnetic field, which protects us from solar and cosmic radiation, could be weakened or even destroyed by gravitational interference, exposing the Earth's surface to lethal levels of radiation. If the wandering star had a planetary system of its own, the situation could become even more unstable. The presence of exoplanets orbiting the invading star could introduce new celestial bodies into the solar system's trajectory, increasing the risk of collisions and gravitational distortions. The combination of a wandering star and its possible planets could act as a gravitational projectile, hurling smaller bodies, such as moons, asteroids, and comets, toward the Sun or the inner planets. The question is, what would happen to Earth if a wandering star got too close? The gravitational impact could rip Earth from its orbit and launch it into interstellar space, condemning the planet to a fate of extreme cold and perpetual darkness. Life dependent on the Sun's heat and light would collapse in a matter of weeks. Temperatures would drop to hundreds of degrees below zero, the oceans would freeze, and the atmosphere would begin to disappear as gases were lost to the vacuum of space. But the worst-case scenario wouldn't just be the destruction of the Earth, it would be survival in a state of eternal darkness. A planet wandering through space without the protection of a star, completely isolated, condemned to an endless cycle of freezing and darkness. Some scientists believe that rogue stars passed close to the solar system in ancient times, disrupting the Oort cloud and sending comets hurtling toward the system's interior. Gravitational evidence suggests that these interactions may have been responsible for mass extinction events on Earth, such as the impact that wiped out the dinosaurs 66 million years ago. You know what's scarier? This possibility is not just a hypothetical scenario. Wandering stars have passed close to the solar system before, and there is scientific evidence that such events may have triggered mass extinctions on Earth. If a new wandering star were already on its way, unseen, hurtling through deep space right now, how do you think humanity would react? The information you just heard is not something you find easily. The universe is uncharted territory, full of forces that we cannot control or predict. Leave your like now, so that this type of content continues to be explored and discovered. Your like is like a signal to the algorithm, a way of showing that mysteries like this deserve to be debated and unraveled. And the most intriguing thing is that some scientists believe that a wandering star is already approaching, slow, silent, from a dark region of the galaxy. What would happen if it was closer than we imagine? In the next section, you will discover the signs that indicate that the impossible may be about to become reality. Gravity is the force that keeps the solar system in balance. Planets orbit the Sun because gravitational attraction keeps their trajectories stable and predictable. However, if a rogue star got close enough, this external force could destroy this balance. The initial impact would be felt on Jupiter, the largest planet in the solar system and responsible for stabilizing the orbits of the inner planets. If the wandering star created a gravitational force strong enough to displace Jupiter, the consequence would be a domino effect throughout the solar system. The change in Jupiter's position would immediately alter the trajectory of the smaller planets, including Earth. Earth's orbit could be pulled closer to the Sun, causing temperatures to rise rapidly, evaporating oceans and destroying the atmosphere. The extreme heat would make the planet uninhabitable in a matter of weeks. On the other hand, if Earth were pushed into a more distant orbit, temperatures would drop to extreme levels, causing a permanent global winter. The oceans would freeze, photosynthesis would cease, and life would collapse. In addition to orbital changes, the gravitational pull of a wandering star could generate internal stresses on Earth. The Earth's crust could be stressed, increasing seismic and volcanic activity. High-magnitude earthquakes could destroy mountain ranges and open giant fissures in the surface. Supervolcanoes, which are currently dormant, could erupt, releasing ash and toxic gases into the atmosphere, blocking sunlight and causing a volcanic winter on a planetary scale. The tides would also be affected. The wandering star's gravitational pull could distort the oceans, generating tsunamis hundreds of meters high. Coastal cities would be leveled in a matter of hours, while sea levels would fluctuate violently, flooding entire continents. Another dangerous effect would be on the Earth's magnetic field. The proximity of the wandering star could weaken or even destabilize the magnetic field, which protects us from solar and cosmic radiation. Without this protection, the atmosphere would begin to dissipate into space, exposing the Earth's surface to lethal levels of radiation. If the errant star were a brown dwarf or neutron star, the danger would be even greater. The radiation emitted by these celestial bodies could sterilize the Earth's surface, eliminating any complex life forms. Even if the planet remained in orbit, the atmosphere and oceans could be destroyed by radiation, turning Earth into a radioactive wasteland. What makes this scenario even scarier is that the gravitational impact would not be instantaneous. The orbital displacement process could take years, leaving humanity in a constant state of panic and uncertainty. Scientists could predict the shift decades in advance, but without the technology to alter Earth's orbit, nothing could be done to stop the planet's fate. The question is, if the solar system's orbital balance is broken, how would humanity react? You will now discover what would happen to Earth if its orbit were truly altered, and why this scenario could seal the fate of civilization forever. If a rogue star were to disrupt Earth's orbit, the planet could be ripped out of the habitable zone and launched into deep space. Without the sun's light and heat, surface temperatures would quickly drop below 100 degrees C. The oceans would begin to freeze, forming layers of ice that would cover even the depths. Photosynthesis would cease, and the collapse of the food chain would occur at an accelerated pace, eliminating most life forms in a matter of weeks. Without the sun's heat to drive winds and weather cycles, the atmosphere would enter a state of stagnation. The winds would cease, and atmospheric pressure would begin to drop as gases were released into space. The planet's surface would be plunged into permanent darkness, with the sky completely black and no visible stars. Life could temporarily persist around hydrothermal vents at the bottom of the oceans, which depend on geothermal heat rather than sunlight. However, without the gravitational influence of the sun to maintain the planet's internal heat, the Earth's core would begin to cool, leading to the extinction of even these extremophile life forms. The psychological impact on humanity would be devastating. Knowing that the planet is doomed to wander aimlessly through space could trigger the collapse of social structures. Governments would collapse, and the fight for resources would become brutal. Humanity could try to create artificial sources of heat and light, but without an external source of energy, these solutions would be temporary. If Earth were launched into deep space, would that mean the end of humanity or the beginning of a new cosmic era? Would life find a way to adapt amidst the void, or would this event completely redefine the concept of civilization and existence? Now, I want to know what you think about this. Do you believe that humanity would have the capacity to evolve to survive on a planet without a star, or would Earth's fate be sealed from the moment it was ripped from its orbit? Leave your opinion in the comments. I want to understand how you see this extreme scenario and what theories you think could explain an event of this magnitude. The only hope would be an unlikely encounter with another star that could gravitationally capture Earth, but the likelihood of that happening is extremely low. Stay here with me, because you will discover what would happen to the other planets in the solar system and why the fate of Earth may depend on Jupiter's behavior. If a rogue star crossed the solar system, the planets would be forced to respond to the new gravitational force, generating unprecedented orbital instability. Mercury and Venus, as they are closer to the Sun and have smaller masses, would be the first to feel the impact. The wandering star could pull them out of their orbits, launching them toward the Sun, where they would be destroyed by the intense radiation and heat. Mars, with its thin atmosphere and barren surface, would face a similarly brutal fate. The wandering star's gravitational pull could strip away its already weakened atmosphere, leaving the planet even drier and inhospitable. Gravitational instability could also trigger intense dust storms, covering the Martian surface for months and making the planet even more hostile. Saturn, with its complex ring structure, could have its orbit altered, resulting in partial or complete fragmentation of the rings. The resulting debris could be dispersed into space or even captured by other orbits, generating an unstable gravitational environment. Uranus and Neptune, as they are further away from the Sun, could be pulled into more elliptical orbits or even ejected into interstellar space. The change in the orbits of these giant planets would create a gravitational chain effect, affecting the balance of the moons and the trajectories of the smaller bodies around them. The asteroid belt between Mars and Jupiter would also suffer disturbances. The wandering star's gravity could dislodge part of these rocky bodies, altering their orbits and transforming the belt into a zone of instability. The true impact of this orbital movement will be analyzed later. The gravitational reorganization caused by the wandering star would not just result in orbital shifts, it would completely redefine the dynamics of the solar system. Planets could be attracted to new gravitational centers or even be ejected into deep space, leaving the solar system fragmented and unrecognizable. If Saturn and the gas giants are dislodged from their orbits, could the solar system find a new gravitational balance, or would the chaos become permanent? If a rogue star crossed the solar system, the resulting gravitational imbalance could trigger a series of devastating collisions between asteroids, moons, and even planets. The asteroid belt between Mars and Jupiter, which remains relatively stable today, would be the first to suffer the effects of this gravitational disorder. Thousands of asteroids could be dislodged from their orbits, crossing the inner solar system on erratic trajectories. The chances of a collision with Earth would increase dramatically. Even an asteroid just 10 kilometers in diameter could release energy comparable to that of millions of nuclear bombs, generating global fires, seismic shockwaves, and a nuclear winter that could last decades. Earth's atmosphere would become saturated with dust and particles, blocking sunlight and causing ecological collapse on a global scale. But the danger would not only come from asteroids. The moons of giant planets, such as Jupiter and Saturn, could be ripped from their orbits and thrown on unstable trajectories. A collision between one of these moons and a smaller planet, such as Mars, could displace it from its orbit and trigger a chain reaction that would affect the gravitational balance of the entire solar system. Furthermore, gravitational displacement could launch comets from the Oort cloud into the interior of the solar system. These comets, composed of ice and volatile material, could release enormous amounts of energy when they collide with a planet or the errant star itself. The release of toxic gases and particles after this type of impact could contaminate planetary atmospheres and alter the chemical composition of nearby moons and planets. Another dangerous effect would be the destruction of entire moons by gravitational stresses. The force exerted by the errant star could break up smaller satellites, generating rings of debris that in turn could collide with other celestial bodies. This cycle of destruction could continue for thousands of years until the solar system finds a new gravitational balance, if that were even possible. Saturn and Jupiter, which today act as gravitational barriers, deflecting and capturing comets and asteroids, could lose this protective function if they were displaced from their orbits. Without this natural shield, the inner solar system could turn into a constant impact zone, with celestial bodies frequently colliding in a cycle of destruction and orbital reorganization. Even if the solar system survived this phase of instability, the orbital environment would remain unpredictable for millennia. The risk of collisions between planets, moons, and space debris would be a constant threat, turning the solar system into a gravitational battlefield where balance would never be completely restored. If the solar system entered a cycle of constant collisions, would this mean the inevitable end or the beginning of a new cosmic phase? Could gravitational chaos create a new balance, reorganizing the solar system in ways we cannot yet imagine? What's more, if planets were ejected or destroyed, how do you think that would affect the gravitational behavior of the entire system? Leave your comment below. I'm curious to know what you believe would happen in such an extreme scenario, but the true impact of this gravitational chaos would not just be in space. It would directly affect life on Earth in ways that few can imagine. If the orbital balance were broken, the natural forces that sustain the climate, the oceans, and even the cycle of life itself could collapse. What would happen to human civilization in a world where every day could be the last? You will find out next. If Earth were to survive the gravitational impact of a rogue star, the world would be plunged into an unprecedented state of chaos. Extreme temperature variations, the collapse of ecosystems, and the scarcity of natural resources would create a hostile survival environment where social and political structures would be unrecognizable. With the destruction of the natural cycles of rain and evaporation, the supply of drinking water would become unstable. Rivers and underground aquifers could quickly dry up or become contaminated by toxic deposits released by seismic activity. The lack of drinking water and food would lead to a wave of global hunger, increasing conflicts between social groups and nations. The technological infrastructure would also collapse. Without reliable communications and power supply systems, transportation, commerce, and industrial production would be disrupted. Large cities would become risk zones where the lack of electricity, transport, and security would create a scenario of disorder and violence. Governments would have difficulty maintaining control in the face of a scenario of social disintegration. The collapse of supply chains and healthcare systems would result in outbreaks of disease, famine, and mass violence. Armed factions could emerge, taking control of strategic territories and imposing authoritarian regimes to guarantee access to basic resources. In a desperate effort to keep civilization functional, some nations might attempt to establish self-sufficient systems in isolated areas. Underground cities could be built to harness Earth's internal heat as a source of energy and shelter from cosmic radiation. Control over these shelters could lead to even deeper social divisions, with an elite sheltered in safe environments while the rest of the population faces extreme conditions on the surface. Social inequality and the struggle for survival would redefine global power dynamics. Resources such as water, food, and shelter would become the new currency of exchange. Small, organized groups could establish tribal systems, returning to a dynamic of primitive survival, while more developed societies would struggle to maintain a minimally functional political and economic structure. Humanity would be faced with an existential dilemma: adapt to this new world, or disappear under the weight of the cosmic forces that would now control the destiny of the planet. If the world were reduced to a constant struggle for survival, would humanity be able to find a new social balance? You will find out if science could actually find a solution to escape this fate. If a rogue star were on its way to the solar system, humanity would have very little time to react. The initial gravitational impact could be detected decades in advance, but the real challenge would be finding a viable solution to avoid orbital collapse and the gravitational chaos that would follow. One of the theoretical possibilities would be to modify the Earth's orbit using gravitational propulsion. This technique would involve manipulating the gravity of nearby celestial bodies, such as the Moon or even asteroids, to generate a counterforce and alter the Earth's trajectory in relation to the intruding star. However, this would require extremely precise gravitational control and technology that is still beyond our reach. Another hypothesis would be to use a particle shield, a barrier composed of magnetically charged or highly reflective matter, capable of attenuating the gravitational pull of the wandering star. For this to work, the shield would need to cover a colossal area and be supported by a level of energy that exceeds humanity's current productive capacity by millions of times. A more radical solution would involve installing gravitational thrusters directly into the Earth's crust or on orbital platforms. These thrusters could generate a constant thrust, slowly moving the Earth to a new orbital position. The problem would be the scale of this operation. To move an entire planet without destabilizing its internal structure, it would require a level of engineering and material resources that is unimaginable today. Faced with the difficulty of saving the Earth, some scientists believe that the best alternative would be to escape the solar system. This could be done by building generation ships, self-sufficient structures capable of supporting human life for hundreds or thousands of years as they traveled through space in search of a new habitable star system. However, the time needed to develop this technology and the amount of resources involved would make this plan viable for only a small fraction of the population. A less complex alternative would be to try to colonize Mars or the moons of Jupiter and Saturn. However, the gravitational instability caused by the wandering star's passage would affect these celestial bodies as much as it would Earth, making any attempt at colonization a temporary and risky solution. Furthermore, the harsh environment and lack of a stable atmosphere would make survival on Mars or any other moon a permanent challenge. The question is that all theoretical solutions depend on a level of technology that we do not yet possess. For any of these strategies to work, humanity would need to achieve a technological leap equivalent to millennia of progress in a matter of decades. If science is unable to find a way out, the fate of humanity would depend solely on luck and resilience. Surviving an event of this magnitude would require more than technology. It would require a complete reorganization of society, economics, and politics on a global level. But the time to act would be short, and the future of civilization could be decided in a matter of years or even months. If current technology is not sufficient to face an event of this magnitude, would humanity be able to adapt instinctively, or would we be doomed to extinction? Few people have access to this type of information. The idea of a rogue star destroying the solar system isn't just a science fiction scenario. It's a real possibility that few are prepared to understand. You need to share this video now with that friend who is also fascinated by the universe. Let's spread this discussion and see where this theory can take us. The more people are thinking about this, the greater the chance of finding answers to the mysteries that the cosmos still hides. Comet fragments, orbital changes, and even mass extinctions may have been caused by encounters with cosmic forces we can barely understand. And the most disturbing thing is that similar signs may be appearing again. Look, there are about 70,000 years, a star known as Schultz star may have crossed dangerously close to the solar system, leaving gravitational marks that can still be detected. Schultz's star, a red dwarf with approximately 9% of the Sun's mass, would have come within less than 0.8 light-years from the Sun, an incredibly short distance in cosmic terms. For comparison, Proxima Centauri, the closest star to us today, is about 4.24 light-years away. The passage of this star would have caused significant disturbances in the Oort cloud, a vast region made up of trillions of comets and icy bodies that surrounds the solar system. The gravitational pull of Schultz's star may have dislodged some of these bodies, sending comets into the inner solar system and increasing the risk of collisions with inner planets, including Earth. Some mass extinctions and impact craters on Earth, such as Chicxulub crater, associated with the event that extinguished the dinosaurs, may have been caused by celestial bodies displaced after gravitational disturbances of this type. Studies indicate that encounters with wandering stars can occur in cycles that vary between 500,000 and 1 million years. Although most of these passes happen at a safe distance, the risk of a direct gravitational encounter, capable of causing an orbital collapse, is real. If events like this have happened before, what guarantees that a new wandering star isn't approaching right now? A wandering star could change everything we know about the solar system and life on Earth. Would it be the end of an era or the beginning of a new cosmic cycle? The history of the solar system has been shaped by encounters with unseen forces, and the next event may already be in motion, silent, inevitable, and completely beyond our control. Now, I want to ask you a different question. If a rogue star really were on a collision course with the solar system, what do you believe would define humanity's destiny? Technological advancement or our species' ability to adapt? Would the survival instinct be enough, or would we depend entirely on science to escape this fate? Leave your theory in the comments. I want to understand how you imagine this extreme scenario and what humanity's true chances of survival would be. You know that the universe is much more mysterious than we imagine. Being part of this is more than watching videos. It's exploring the unknown, challenging logic, and seeking answers to questions that science has yet to explain. Here, each question leads to a new mystery, and each theory opens doors to answers that can change our perception of reality. If you are not yet part of this journey, sign up now and discover what's next, because there's so much more waiting to be explored. And what you just saw is just one piece of the puzzle. The next revelation could change everything. Some answers lead to even more mysterious questions, and what comes next may defy even the laws of physics as we know them. Get ready for the next video, because the mystery is just beginning.